Unit 4, this is electrical resistance part 1. This is going to be using resistance equations. One of the most important laws that you have in electricity is V equals IR. V stands for voltage, I is current, and R is resistance. Alright, now if you rearrange Ohm's law, you are going to have resistance equals voltage divided by current, and that's what we're going to be looking at next. Alright, your electrical resistances are, sometimes they'll use an E to represent electrical, and it's measured in ohms. Your voltage, alright, is delta V, and it's measured in volts. And current is I, and it's measured in amps. Alright, here's the question. What is the resistance of a light that has the voltage difference of 12 volts and the current is 2 amps? Alright, what is the resistance? Kind of redundant there, but it's going to be R equals V divided by I, and your voltage is 12 volts, and they tell you your current is 2 amps, so it's going to be 12 volts divided by 2 amps equals 6 ohms. Now, resistance, basically what it is current is electrons that travel through a wire. And what we want to know, that the three factors that affect resistance are going to be length, area, and resistivity of the material. Now, excuse me, what that means is that the electrons, sometimes they can travel well through a substance and sometimes they can't. And these are the variables that are going to determine that. The analogy that I would use would be, think of a hallway, all right? And depending on how tired you're going to get, all right, if you're the electron, all right, is going to be determined by how far you have to run. So the longer the hallway, the more tired you're going to get. And the thing with resistance is that the more tired the electrons get and hot and bothered they get, the higher the resistance goes. All right, so you don't want them to be hot and tired. Now, area. Let's say we reduce that hallway so that it was narrow enough so that you're only getting, let's say, it was only 1.5 persons wide, and that the electrons, all right, are trying to fight their way through, and they have to push each other out of the way, and they're bumping and all that kind of stuff. All right. If you were running down a hallway like that was very narrow, you would be banging into other people. You get hot and bothered and irritated very quickly. Electrons are no different. All right? So the smaller that area that they have to pass through, the more agitated and tired they're going to get. Now, the resistivity. Now, materials are all different. All right? The resistivity would be like this. If you were running down this hallway and people are at various doors, all right, I'm thinking like a school hallway, you have classroom doors, and you had people at the doors, and here and there you were getting hit with water balloons. That would be a low resistivity. But let's say that at every door they had all kinds of things they were going to be tossing out that door, like chairs and water balloons and rocks and marbles and all kinds of stuff. The more you get of that, the more resistivity you would have. Okay? And the more resistivity you have would be the warmer or hotter that the wire is going to get. So what is resistivity? It's the capacity of a wire to resist the electric current. It's going to make it hard for those little electrons to travel through. Okay, another equation that we use is electrical resistance is resistivity times length divided by area. Resistance is still R and measured in ohms. Resistivity is a small r and it's an ohm centimeter. That means they're times. Length is L, measured in centimeters. Area is A and it's square centimeters, which means centimeters times centimeters. Here's the problem. What is the electrical resistance of a wire that's 400 centimeters long, has an area of 0.1 square centimeters, and has a resistivity of 0.02 ohm centimeters? Alright, so here we have our resistivity. Our length is 400 centimeters right here. And you're going to divide that by the area, which is 0.1 square centimeters. Your centimeters here when they're multiplied together, you're going to get ohms times square centimeters. All right, square centimeters are going to cancel out with this underneath in the denominator, and you're going to be left with ohms. And when you multiply, all right, these and divide by 0.1, you're going to get 80 ohms. And that's simply how it works. All right, some other properties of materials when you're talking about resistance. There are three basic materials: conductors, insulators, and semiconductors. Conductors are those things that allow the easy flow of electrons, like metals. All right, insulators are those materials that do not allow the electrons to travel through them very easily. Usually you're thinking of anything that you would coat wiring, so it would be like the plastics, rubber, porcelain, glass, those kind of things. And then you have also what are called semiconductors, which means that they have the properties of both conductors and insulators. And this here is a very interesting section, because if you wanted to go back and take a look at the importance of semiconductors, semiconductors are one of the reasons that we have the small technology today, that we went from those huge mainframe computers that took up, a whole room, versus you've got more on your cell phone than they had in those big mainframes. Okay, and the reason for that are semiconductors, and some of the examples would be like silicone, germanium would be some examples of the semiconductors. All right, now there are types of resistors. Right, there's two types. There's a fixed resistor, which means it is a certain resistance, it doesn't change. And then you have a variable resistor. A dimmer switch would be an example, and there are different kinds. But a dimmer switch, like if you have one in your bathroom or your dining room, which usually rotates, all right, and what it does is you can either brighten or you can lower the lighting. Okay, you have something similar, like you have a dimmer switch in your car. All right, you can lower and raise. Like in my car, I have it looks like a little wheel. All right, and you touch the side, and it can either increase the light that I'm getting off the dash or decrease it. Okay, so that's an example of a dimmer switch. Now, the pictures that you have here, these are fixed resistors. And one of the things I want you to notice is they have bands of color on them. It's these bands of color that actually you can read, and I'm going to show you how to do that. You can read those bands to determine how much resistance each of those have. By today's standards, these are very, very teeny. And if you were an electrical technician and you were putting together circuit boards that had resistors, you would be using a magnifying glass to actually solder them in place, because they're that teeny. Alright, so here's our example. We have an orange band, a green band, a brown, and a silver. Alright, and if you look at the next page, you will see that we have colors, and then associated with each band, alright, we have numbers. Okay, and we had an orange band. Okay, we had a green band, and I believe we had a brown band, and then we ended with the silver. Okay, and I'm going to go back to that slide. Alright, so the orange. For the first band that you have, you look up orange and it's 3. The second band you have, it's green and it's 5. So what you do is you put them side by side, and what do you have? You have 35. The third band is what is called a multiplier. Alright, that means you're going to take that 35 and you're going to multiply it by that number. And what you'll notice is, when you look at the chart, is that they are based on 10. You can have 1, 10, 100, 1,000, and so forth. Alright, and then the fourth one is what is called a tolerance. Alright, in this case, silver is plus or minus 20%. Okay, so basically when you put all this together, what do you have? You have 35 times 10, which will give you 350 ohms. The tolerance is a plus or minus 20%. Okay, so if you wanted to figure this out, what would happen is what they're saying, that it should fall within a certain range. So we have 350. All right, it would be 20% on either side of that. All right, and 20% of 350. All right, if I'm doing my math correctly here, should be what, 70 points on either side. Let me just double check that. No, 7 points. I'm sorry, I did too many. So it would be either 200 or 343 to 357. Okay, so that would be the range. I thought 70 sounded like too much, but that would be your 20%. And then you have these colors, like I was telling you. Notice that what's kind of interesting, if you went to the Career and Technology Center and you had electronics, you would have these memorized. They actually have a mnemonic device to know those. I'm not familiar with that. The kids have told me that it's a little risque, but that they learned. But there is actually a mnemonic device to use. And then notice how you add a 0 each time you go down. Okay, so there are patterns. I always want to look for patterns. It makes life a lot easier in science when you do that. All right, well, that wraps up our part 1 with the equations. Have a good week.